Welcome to my talk, Smartwatch Lobotomy. For those of you reverse engineering a cheap smartwatch and making it do what I want. My name is Dale Nunns. By day, I'm a team lead and senior dev at Structure.it. I help build big data solutions for financial markets. In my free time, I take things apart. My best description of who I am is I'm a jack of all trades, serial skill collector, and high-functioning hoarder, although my wife will tell me that last bit is a lie. My goal is simple. Reverse engineer a cheap smartwatch and make it do what I want. Or it's justify the cheap smartwatch I added to my Takealot order to qualify for free shipping. Don't laugh, we've all done it. So how hard can it be? 7 months later, I learned some things. This talk is those things summarized in about 200 slides. I apologize, couldn't get it less. This is the cheap smartwatch. It's a Focus Fit Pro Y68. It's also known as a Smartwatch Y68. The Smart Activity Fitness Tracker Y68, the D20 Y68 smartwatch, the Y68 Macaron Color smartwatch, or my personal favorite, the Yeet 68 smartwatch. Yeah, that's what I want to do to it too. The watch costs between 100 and 200 Rand, or for those of you who don't speak Rands, that's about 2 to 4 Big Mac burgers. It's available locally on Takealot. All those watches are the same one. You'll note the prices range from about 199 to about 699 Rand. You can get them on one day only. You can buy 2 on special often for 369 or thereabouts. If you're going to do that, remember, 2 is 1, 1 is none. So buy 10. Again, please don't tell my wife. She's going to kill me. This is the claim specifications. Again, these are all over the map as you look at the various things, but more or less they come around to this. They claim a 1.3-inch screen. They claim it's IP67 waterproof. There's some chipset with a whole lot of things there. 150 milliamp hour lithium polymer battery, heart rate detection, 10 days standby time, and about 2 hours to charge. Actually, it works out to this. Yes, it has a screen. No, it's not waterproof, and I wouldn't wash my hands wearing this or sneeze near it. The chipset's actually a TLS R8323. The battery varies depending on which watch you take apart. It will have 100 or 150 milliamp hour battery. Heart rate detection we'll come to later. Standby time varies as well. It's somewhere between an hour and 3 days, depending on the watch, depending on the weather and whether or not you look at the thing. And yes, it does take about 2 hours to charge. It's available in many colors. Basically, they just swap out the watch band, and then for this white one, which is slightly more expensive, all they've done is spray painted the plastic silver, and it just rubs off. This is the watch without the watch straps. On the left is the front, on the right is the back. This is how you charge it. Yes, you rip the band off, and then you plug that in to an extension USB cable. Yes, you're going to get it wrong way around at least once. Yes, it doesn't make proper contact, and no, it doesn't charge properly on this. Also, they don't supply that extension cable. That's my own one. So if you buy one of these watches, you can't plug it into most devices because of the weird angles and everything else. This is the fancy UI that pops up. It does look nice. It does all the normal functions. That is the touch screen. Now let me highlight the touch part of that. There, that's it. The UI works like this. You touch that little spot. There's only 2 ways of doing a touch. It's a long touch or a touch. And the whole UI is built like this. It's horrible to use. It's horrible to navigate. And if you sneeze on it, or your finger's a little bit cold, or anything else happens, it will either trigger 40 touches, or it won't register a touch. The software. Okay, so it requires an Android app to talk to the watch. That's the Android app. It's called Fit Pro. It actually works with a whole range of watches, not just this particular watch. It's your generic fitness app. It does heart rate and a few various functions and notifications and things like that. It talks over BLE to the watch for what I assume is power-saving reasons. I'm going to give them the benefit of the doubt here. The watches are terrible at Bluetooth. They'll lose their connection. They won't respond to commands. Sometimes they just sort of freak out and don't do anything. If you do tap them and keep them awake, they're slightly better, and they will occasionally connect. The official app solves this in a very clever way. Essentially, they cache everything and queue everything. What you see in the app could be anything from 5 seconds to 5 hours out of date. And that's it. That's how they solve it all. If you scan the device, so this is using a very cool app called NRF Connect. I think it's available also on iOS and things like that. I just run it on Android. You can scan all these BLE services. So these are all the services that are being exposed by the watch. And you'll see most of them are just generic access, generic attribute, things like that. There's a very cool one, device information, and then there's battery service. So if you look at the battery service, for example, you can then expand it, and you can see I can get the battery level of the device. And you can do the same through GAT tool on Linux. I think this is available on other OSs, but Linux works a lot better at this kind of stuff. So you run the GAT tool, it gives you a value, and then if you convert that value into decimal, you'll get a value of 100%. Device information is similar. You can access the device information over BLE using NRF Connect, and there you can see you get a serial number, and you can do the same thing using the GAT tool, and you can pull it. So it's nice. But obviously I want to do more. So this is where the fun starts. Let's get into software and reverse engineering. So for those of you who don't know, the idea here is I'm going to decompile the app, I'm going to poke at the internals, and it's pattern recognition. I'm looking for things that look familiar, and I go from there. You make a few guesses, you're going to go down a few blind routes, but it's fun. Tool I'm using for most of this is Dex to do Java decompiler. It's called JADX. Basically, you just take the APK, you dump it in this tool, and then you get mostly Java code out. It's sort of, think of it as the Google Translate. Like if you've taken Chinese and converted to English and it kind of makes sense, this is what this code will look like. So let's take this, make it a little bit simpler. Let's find the find function on the app, look for it in the code, and yeah, you can see we can find, if you've done any Android development, you'll understand the stuff. There's the entry it runs. And so you slowly dig through. So you can get the individual bytes that are sent through to the device, and we can send those bytes. So we're getting the various bytes. You can see it gets written to a particular command pool, which is just like a queue. And then deeper in the code, this all gets written to a char, a characteristic. And there's the UUID. I know I'm skipping through this. We'll get to the point why now. And then, okay, so now I know. I need to send these bytes to this UUID. So it's simple. We run a scan. This is on Linux. You can do similar things on Windows. Scan for the device. I find my MAC address. I then connect to that MAC address. I get the various, the characteristic. I'm looking for the handle here, and I get the handle. Once I have that, I can put a command say it. So now what I've done here is I've got the MAC address followed by the characteristic that I'm writing to, the handle for that, and then I'm saying write this hex value. Now that there's that magic byte string that's going to send it the find command. And if I do that, that happens. There we go. As you can see, my watch is busy vibrating and showing off. Now you can do the same with notifications. Again, I'm not going to go through all the code. There's quite a lot of stuff. But basically, I've dug through the layers of Java that's there, figured out how it works, and I can do the same thing. So the first command there turns on notifications. So if you've turned off notifications through the app and said, don't notify my watch, I can turn it back on. And then the second command there, or the second two commands, that's sending my notification through. And so obviously, I've done that, and I've sent my watch a notification. You'll note I get a WhatsApp message on my phone saying, Serial, hack the planet. But I haven't touched a phone yet. This is all from my laptop. Anyone notice anything odd? Yeah, you get access. There's no authentication, no keys, no pairing, nothing. So this is how they do security on this watch. The only security on this thing is that you have one connection at a time. That's the only security they built in. And like I say, this watch is terrible at keeping a connection up, so chances are it's not going to be connected to the phone. I mean, this is fine, right? So anyone notice what that one is? Okay, so OTA upgrade. So what does that mean? Well, that's an over-the-air upgrade. And this is used normally for software updates. So again, dig through the Java code, see what's there. And I found that constant.token. Anyone want to take a guess? Yeah, that's nice, eh? There's a bearer token in my code. Okay, so I can make a legal connection to that HTTP endpoint, can't I? So yeah, I do. Unfortunately, it doesn't come back with firmware because there's no software updates. And a few of my friends poked around, and there are other watches updates, but not for this particular watch. So dig through the code a little bit more, and you can find that there's a start OTA command. Along with that, there's various other commands. So there's a prepare command, a start, and an end command for doing an OTA. Along with that, it's basically you stream a bunch of bytes over the Bluetooth connection, and the device will update. So I'm going to dig through, and I'm going to get what characteristic. This is like the end point in the BLE terms that I'm writing to. And again, I'm going to send one of these commands. I mean, what could go wrong? I can try this. I know what I'm doing. Yeah, so I'm going to dig through the device, find the characteristic, and then from there, I'm going to send it the following command. So I'm sending it the 0xFF. Basically, I'm saying start an OTA update. And the device switches off, and it doesn't come back, no matter what I do. So I scan for the device, and this comes up. T-Link, remote. Now, T-Link is the company that makes the chipset, and that's all that happens. So did I just brick my watch? Now, for those of you who don't know what I mean by brick, I basically turned it into a fancy paperweight that kind of is powered and does nothing else. And again, I did this with no authentication, no keys, didn't have to pair, and it gets worse, no validation checks. I can brick one of these watches by sending it 2 bytes, well, 1 byte, 2 bytes, over Bluetooth with a MAC address. That's all I need. So I hope none of you have one of those. Again, this is fine. So, oh, my word. Yeah. Hang on. 100 slides. Cool. Oh, yeah, that's cool. Okay. So this is what happens when you talk with your hands. You throw things. Okay, so now what? I've got a brick device. When you do what everyone does, you pivot. So let's switch to hardware. I mean, I'm a hardware hacker. I can do this. So this is the inside of the display. To get to this point, you basically just lever off the plastic cover and it just pops off. That's the display. There's the display connector at the bottom. This is the inside. The big bulgy thing at the bottom, that is a lithium battery. Please note the piece of Captain sticky tape protecting it at the end, and that is all that stands between your lithium battery and water, because the cover has got holes in it. Above that little round thing, that's the vibration motor. This is the HeartFlex PCB, so this is a flexible PCB at the bottom of the thing that does the heart rate monitoring. That's the PCB board. We'll get into that soon. And again, I'm now going to do a little bit of hardware reverse engineering. For those of you, it's the same thing. It's pattern recognition. It's looking for things that look familiar. I don't know what half of these things do. Google's your friend. So it's simple. Identify any of the components and Google them. If Google doesn't find it, you use Bing, you use DuckDuckGo. If none of those work, you use Yandex, which is a Russian search engine. Google translates your friend. If that doesn't work, you use Baidu. If that doesn't work, search on AliExpress. Because you know what? Some Chinese guy is selling a few of these that he swept off a factory floor, and maybe he's got a data sheet there. If that doesn't work, you try Taobao or Alibaba. Same deal, you'll find someone selling one of these things. Just make use of Google Translate. The general rule when doing this kind of thing is anything with 3 legs is probably not that important, can be safely ignored. That is the board. As you can see, I'm just going to look for the names. There's 2 red things there. Those are NPN transistors. Basically, think of them as switches. They got 3 legs. We don't care about them. There's a MOSFET there. Again, 3 legs. We don't care about that. And then there's the purple one. That's the voltage regulator. Again, it's an important part, but we don't care about it. It's got 3 legs. These start becoming important. So at the top, the blue thing, that is the battery charger IC. That handles all the battery charging and all that kind of stuff. That gets kind of interesting. Next one down, that orange thing there at the bottom, what that is that handles that fancy capacitive touch spot. Is all done with that fancy little chip. And then the purple thing, I think, is an accelerometer. I haven't figured it out, but I'm guessing this watch has got something to figure out movement, and the most likely thing is an accelerometer. It could be an IMU, but I doubt they've gone that fancy. And then the single most important part on this whole board is the big one with the lots of legs. Again, number of legs tends to be how important things are. So in this case, this is a T-Link TLSR 8232 24-pin Bluetooth SoC. For those of you who don't know, SoC means system on chip. This is the HeartFlex PCB. The components on here are really interesting. So we'll start with the one highlighted in red. That's a green LED. The one highlighted in yellow, that's a green LED. And the red one's an SMD resistor. Now, I'm not an electronics engineer, but I'm pretty sure that LEDs can't read heart rate, which explains why my banana's got a 73 beat per minute heart rate. Yes, they've faked the whole thing. There's a random function. It figures out what my a random heart rate. You'll also note it's got blood pressure as well. That's pretty cool. And yeah, you'll see it's got 95% oxygen levels. Like amazing banana. So this is the internals. These are test points. So during the manufacturing process, they probe these to make sure the device is working or not working. There's nothing very interesting there. You've got a serial one and a TX and RX are for serial. There's nothing on those. I've checked them. On the other side there's power, ground, a data pin or a DAT pin. I don't know what that's for, but it's not actually doing anything. And then the most important pin is the SWS, which is a debug interface for the Bluetooth chip. This is the Bluetooth chip. Sort of a block diagram. You'll see it's got I2C, which is used for inter-chip communication, SPI, which is used to talk to the screen. It's got a UART, it's got these GPIOs, which are called general purpose I/O pins. It's got a Bluetooth radio, it's got clock, it's got memory. This particular model's got 16K of RAM. Makes your little desktop computers look tame, doesn't it? And it's got a 512K of flash. So, like I say, it's just 16K of RAM, 512K of flash, a whopping 24 megahertz processing speed. It's got a proprietary one-wire protocol that's called SWS or S-wire, depending on which page in the PDF you're reading. And the instruction set's a proprietary one called TC32. Again, TC32 is actually a clone of a 16-bit ARM thumb instruction set. With a few tweaks, just enough so that they can't get into trouble for cloning it. SWS, you can buy a debug interface to program this. The programmer is only 419 Rand on Mauser. It's 750 Rand to ship to South Africa. I didn't buy one. I tried the open source ones. There's a very cool project that, in theory, should be able to talk to these. And you just install it on one of these little Blue Pill STM32s. And then that you hook up to the watch. Unfortunately, it doesn't work. And the reason it doesn't work is there's no reset pin on the 24-pin version of this Bluetooth adapter. So the reset pin holds the chip in this sort of reset state, and then what it will do is let it go and start executing instructions. The minute it lets it go, the SWS kicks in and pounds the chip and says, hey, listen, come speak to me instead of running your normal code. The other problem with this particular chip is that the SWS pin is also connected to those blinking LEDs that read my heart rate. So it makes it very, very hard to connect to it. And I found that none of the open source programmers will work. So I did the only logical thing, and I went and bought the stupid programmer. Again, please don't tell my wife, but I am speaking at DevConf, so I considered this worth it. The official program is quite nice. I can upload firmware, I can read and write to RAM and flash, I can erase the flash and the RAM, I can halt and single step through the instructions, and I can execute code from memory, and I can inspect the memory. It doesn't work properly. The software will crash. often. The biggest thing is if you have a path with any spaces or the path name's too long, it won't work. It appears to connect to the watch, but only if the watch is running in OTA mode. So if I've done that fancy thing over Bluetooth, where I've bricked my watch, the programmer will connect no problem, but if you're using a brand new watch, it won't connect. Also, the most annoying feature is that its command line mode is only accessible inside of the UI in a little text box at the bottom, named command line. Great, eh? This is a dump, or a flash dump, of the device's memory when it's running in this OTA mode. Please note the white space on the left. What that is all FF. That is where the code should be. But if you put a watch into this OTA mode, the first step it does is wipes out the old firmware in preparation for getting the new firmware that it never gets. Hence why you end up turning them into a brick. By accident, on Friday, yes, this Friday that just passed, while trying to grab slides for this talk, I got it to work. And I only got it to work because my desk is really, really messy, and I shorted the ground and the 3.3 volt pins on my watch. You shouldn't do that, but what happened is it glitched the watch. So by glitching, what I mean is it put the watch into this weird state where it wasn't running instruction code anymore. And at that point, I could run my own code. So I connected, and I dumped the flash. And as you can see, there's pretty pictures on the left where there was previously white space. This is amazing. It means I have finally got a dump of the code. And what do I do with it? Well, I put it in this wonderful tool called Ghidra. For those of you who have never heard of this Ghidra, it's a reverse engineering tool. It's decompiler and it's a disassembler. And it's developed by the NSA. Yes, that's NSA. It's really, really cool. With that, I used a plugin called for this TC32 architecture, which you can find online. It's a little bit buggy, but it did the job. So you combine that with Ghidra, you can pull the code in, and there I have Ghidra running, decompiling the code. And as I work through this, this is more or less how, at this point, my guess of how this hardware hooks up. I've got the chip in the middle, which is Bluetooth. I have the LCD, which is most likely connected over this SPI because it's fast. I have this accelerometer, which is most likely connected over ITC because that's what accelerometers is normally connected to. And then I have the rest of the stuff is probably connected to the GPIO pins. I have no clue if any of this is correct. I'm just taking a guess because you need some way to start. Then you beep it out. You grab yourself a multimeter, you get the sharpest, absolute sharpest pointy things you can, and you poke around on the board, seeing if your guesses are correct. Once you've done that, you end up with something like this. So this turns out to be 100% correct because I've checked it afterwards, but as time goes by, you say, well, this pin on the MCU, on the Bluetooth chip, links to these pins, and that's the vibration motor, and the LCD backlight, and the TX pad, and the touch input and all these kind of things. So once you got that, the next thing I moved on to was the LCD. I know nothing about this LCD. All I know is it's got 13 pins, and I suspect it's connected to SPI, so you Google this. And when you do, you find that picture by someone, and it's got a pinout on it. And that pinout turns out to be correct. Once you know the pinout, you now work backwards, and you figure out which pins on the CPU those connect to. And like I say, you can take guesses here. It's 150 Rand watch. Who cares if you break it? Have some fun. So you figure this stuff out. So now I know enough to, in theory, build firmware for this thing. So step one, I need an SDK. T-Link offer one. It's terrible. It requires an ancient version of Eclipse. It only runs on Windows, and it doesn't work properly, and it's buggy, and it's annoying. Someone else, Raphael, put it all into a Docker container. So he's got the compiler for Linux plus a SDK. It makes life a lot easier. You can write code and you can just build it in this Docker container. So we know enough. It should be easy to just toggle a pin. So that's exactly what I do. Here, I've got some code. It's C. I apologize. And all I'm doing is turning on a pin. You'll see there's a line there, GPIO set func. All that's doing is saying, turn this pin into a GPIO pin. And then after that, I'm turning it into an output pin. I'm disabling inputs. And I'm turning it on. And then in a while loop, I'm just toggling it on and off. And all that does is make it go bzz, bzz, if you've guessed the pin right. And you could do this for the other pins as well. Just be careful with the SWS pin, because obviously if you keep pulsing that one, you can't connect your programmer unless you're going glitch it again. But yeah, I now know what pins are connected to things. Bluetooth is a lot simpler because Bluetooth is all self-contained. It all runs inside of the chip, so all I need to know is how does Bluetooth work. So that one's easy. And then finally, it's the LCD is the hard part. So I spent 3 months trying to get this right, and I only got to it working 4 days ago. I know it sounds like I left everything to the last minute. I promise I didn't. The LCD uses a common protocol for driving these types of displays. All of these LCDs will use it. The main interface is SPI. So you've got a chip select line, a clock line, and a master out slave in line. And basically the data gets clocked in as the clock signal changes. And don't worry, you don't need to know all the details. And then there's a display command which says, I'm sending the screen a command rather than just pure data. So you flip this thing and you say, well, okay, when I pull this low, I'm sending you a command. And then I raise that pin high and I send it the rest of the data. And so, like I say, it's 4 lines. The LCD understands a bunch of basic commands, and most of these LCDs all understand these commands. So they like reset the display, they sleep in, they go, well, sleep out, display on, off, go to this row and column, and start drawing whatever's in RAM to your screen. And these sort of are common across a whole range of these screens that you'll get from places like Adafruit and SparkFun and random eBay sellers and this kind of thing. What differs between each of these things is the display initialization and any additional settings for things like gamma curves and all that kind of stuff that makes the picture a lot prettier. So my plan was I'm going to dump the SPI commands because I don't know them. I have no other way of getting them. So the easiest thing is I solder some of the most tiniest wires I can to the tiniest connector I can, and I hook them up to a logic analyzer. So this is a really, really cheap, dodgy 8-channel logic analyzer. I plug it up to that. And basically, this thing records as the line goes high and low. It records them, and you can then get the sort of pattern for the various pins, and you can load that up into a different tool, and you can decode them. But that's the idea. Unfortunately, it doesn't work because the logic analyzer can't read fast enough. So that's fine. I'm going to use my fancy oscilloscope. So I go and stick the whole lot into the oscilloscope, and the oscilloscope's also got a decoder built into it. But again, this doesn't work. This time, I suspect it's because things that should be squares are sort of rounded off because, again, it's a cheap watch, and there's a whole lot of other stuff all hooked up, and I just can't get a clean signal, and the poor oscilloscope just freaks out. It gives me values, you can see in the green bar there at the bottom, but they're complete rubbish, and they keep changing, and that's how I know they're wrong. Fine. So I go and write my own code. I go and take a Raspberry Pi Pico. I write a whole lot of code to dump the thing using programmable I/O, and I do fancy DMA stuff and all this kind of thing, and I write really, really fast, really optimized code. And it still doesn't work because it's still not fast enough. So I get some of the commands, but not all of them. So none of this worked. I'm guessing it's because it's too fast, or it's out of spec. So like I say, the PO came close, but not well enough. So let's try brute force this thing. So port every LCD driver I could find and run them on the watch. I did this to over 100 different LCD initializations. And those of you who think I'm kidding, there's all the .h files for all the drivers I did. I went through every single one I could find on the internet and put them on. Yeah, I said to you, it took me 3 months. None of that worked. Then Friday happened, and the happy accident. And something cool happened. Ghidra. So over here is the LCD initialization. And here it is, and slightly easier to read. And as you can see, it's calling 4 different LCDs. The reason for this is there's 4 different LCD screens used in these watches. They grab whichever one they can for this particular week and shove them in this thing. So I didn't have a hope because I was dumping this one, but that wasn't the one I was testing my code on. So I might have actually got a right dump from this one, but I was testing on this one. You can't see the differences. So now that I had that, I could dig in and get the initialization code. So this is after lots and lots of cleanup and reading disassemblies and everything else, but thanks to Ghidra, I can get code. Which means I can draw to the screen. So that is my first test screen. This was sent to a couple of my friends on WhatsApp and, very, very early on a Saturday morning because I was so excited I'd finally gotten it to draw. Now, if I can draw that, well, I can draw pictures. So if you follow me on Twitter, you must have seen this. That's me drawing and playing around with the screen. And this is just drawing. I now can draw a bunch of bytes and I can send them off to the screen. And at this point, I've got Bluetooth working, I've got Vibrate working, I've got Touch working, and I've got LCD working. The only two things I haven't got working is the power management and the accelerometer. And the only reason I haven't is because I had to come and talk at this conference instead of getting to play with electronics. So I put it all back together, I loaded my slides onto the talk, and I stuck it all on Twitter. So there we go. Please follow me. I'm on Twitter as Dale_Nunns. I'm on LinkedIn. I'm on Mastodon at Dale_Nunns at infosec.exchange. And otherwise, you can read about this and everything else I do on xor.co.za. There is a much longer write-up about the stuff. There will be more write-ups coming as I clean up all the code and once I caught up on all my sleep after DevConf. And it will all be up there. And like I say, I do this kind of thing quite often. I enjoy taking things apart. Occasionally they go back together. Please go submit some feedback. I believe there's prizes. I'm very, very interested in this prize. I've never taken one of those things apart. So if you can help me win one, that would be great. I promise I'll come back with another talk next year, how I set my house on fire. Anyway, great. That's it. If you have any questions, fire away.
Does Jardex decompile any firmware into Java?
No, it will only do, those were for APKs. So any Android app, it will, most of them. There are limitations, so it only does the stuff that's in the bytecode. But it basically will take any JVM bytecode and decompile it to Java, and that's. So if you do Android development, it's a lot of fun. Just dump your, you're not allowed to do other people's apps. Do as I say, not as I do. Yeah, sure.
Of those 10 watches, how many are currently working?
Well, I have two I haven't touched. Those are my safe two.
That's not the same as working.
Yeah. So I have two that are safe. At least three I killed completely dead. And so that leaves 5 that are in pieces. So to answer your question, not many.
First off, I want to commend your dedication to 3 months to make a screen work, but like, how do you find the motivation and when do you know when to call it quits?
I don't. No, so look, I know it looks like this was, 3 solid months. This is normally an hour, half an hour a day over a period of weeks and months and that kind of thing. And I put it to one side and come back to it when I can. But yes, I don't know when to stop. I mean, it's a 150 Rand watch. I mean, come on. Like, I wouldn't wear it. I wouldn't use it. I bought one, I got curious, I took it apart, and, you go down the rabbit hole.
Just one more question is, do you have any, what are like the other cool things that you've taken apart? Like maybe you've got a blog post that you'd recommend?
Oh.
Diving into?
Oh yeah, the Nest Classic Mini, my friend Ross over there, him and I hacked that one. We've done, I'm trying to think what else is on my blog. I landed up fixing things like laptops and stuff, but the only way I know how to fix it, remove the BIOS chip, reflash it, patch the BIOS, put it back on, things like that. There's one also again, Ross's desktop computer I fixed as well. Similar way was hacking the BIOS and taking things off and stuff like that. I don't fix things the easy way. I don't know why, but yeah.
So through the course of reverse engineering stuff and seeing things down, have you taught you anything about how things should be done?
Yeah, I guess so, like it's more a case of how not to do things. So I don't build hardware for a living, so I'm more a software guy. And generally speaking, a lot of especially the cheap stuff they did it quickly. You can see they did it quickly. So they left out things like authentication and things like that. So stuff like, that's the difference between, say, a Apple Watch and one of these watches, is that Apple spend a lot of time perfecting it and putting all that sort of authentication and validation checks and stuff. I'm pretty sure I can't brick an Apple Watch with 4 bytes. But one of these things, they don't care. They want to get it out as fast as possible. It's a 150 Rand watch. You're trying to get it out the door and in someone's hand. That thing probably costs 10 Rand to make. And that's what happens with a lot of these cheap devices.
Would you consider doing something similar to like a more complex watch in the future?
If someone else is willing to buy me 2 or 3 more complex watches, yes, I'll happily try it. But I don't have the budget to do it to my own watches. But yeah, if anyone wants to buy me one, you can contact me. I'll gladly take them.
Did you leave a review on Takealot?
Yes, but it never got approved.
If BSides gives you a bunch of money to take something else apart and budget, because we're talking about 150 Rand here, let's say it's $150, what would you like to take apart? Like, it doesn't have to be a watch.
Okay, so watches are cool. I wouldn't mind taking some of the drones apart. So there's some very cool drones that have accidentally hooked the Wi-Fi up to everything else in the... So the Wi-Fi is supposed to be only for the camera, but it's also hooked up to everything else. Those ones I wouldn't mind playing with. That's sort of the top of the list, but I don't care. Anything that looks cool. I don't vape, but I was looking that some geniuses decided to put a Bluetooth-enabled vape, and I'm really curious if I can turn it on and push the temperature up. I mean, that would be fun, right? I can see if I do that, I'll never come back here. And what else?
What's your future plans for this one?
So originally when I got it, I'd hoped that it had a heart rate sensor because I wanted to do a speaker thing so that while I'm talking, it will show as my heart rate goes off the roof as I drop things and miss my words and stuff. But I can't do that, so now I'm not sure. Weirdly, I was watching Talia's talk earlier with the sign gloves, and I suddenly realized that I might be able to hijack her gloves and wire them into the watch, and then you don't have to have the massive 3D printed strap on it like she's got at the moment. So maybe that's what will end up happening. I'm hoping to sort of open source all the stuff so that someone else can write new firmware for it. And in theory, there's quite a lot of I/O that's just left open on the device, so you could probably break that out and connect it to other devices and things like that. I mean, again, it's 150 Rand. I mean, like an Arduino costs 30 or 40 Rand. So this one, except this has got a screen and like inputs and everything else. So if you're looking for some sort of device that you can wear, it's not bad. It's not waterproof or anything, but I mean, it's not bad. It's 150 Rand or 100 Rand. If you buy them in enough quantity, you can probably get them for like 50 Rand. Again, if anyone wants to sponsor me, you can contact me. I mean, seriously, I don't mind. I'll happily take 1,000 of those. Don't know what I'll do with them, and my wife will probably kill me, but it'll be fun. Anyone else? Oh, no, this is a Huawei one. I would love to hack it, but again, it was a gift. I think my wife will kill me if I try to play with this one. You can see I'm terrified of my wife.
Would the difference be in strangers gifting them?
Sorry?
If a stranger gifts them to you?
Yeah, no, that's fine. Yeah, like I say, that's fine. I don't have to worry about them.
Has anybody approached you to do this for a living yet?
No. Again, you know where I am. No, so like at the moment, this is just a hobby. But yeah. Okay, thanks very much. You've been great. If you've got any other questions, just come find me.